Morning, grade 8. This is the math video for lesson 4-1, page 151, numbers 17 through 47, the odds, but then also problems 48, 49, and 50. Today's lesson is about factors and monomials, as you can see from the title. Let's start first by talking about what in the world a factor is. Right? If I have a math problem such as the following, 6 times 8 equals 48, in the past we have been told that the answer to a multiplication problem is called the product. 48 is the product of that multiplication problem up there on the board. And we have been told that the two numbers we multiply together, those are factors. Now, in the case of the number 48, there are a lot of different choices of factors we can use to get 48. For example, 1 times 48 gives us 48. 2 times 24 works. 3 times 16 works. 4 times 12 works. 6 times 8 works. All of these numbers are factors of 48. On the bottom of page 148, how interesting, there are some things called the divisibility rules that hopefully by now you're familiar with, but let's review them. If I wrote the following numbers on the board, 6,742 and 6,745, and I said to you, which one of those is divisible by 2? Which one is evenly divisible by 2? The rule says a number is divisible by 2 if the ones digit is divisible by 2. See that on the bottom of 148? That yellow box with the divisibility rules? So let's look at these two numbers. This number is the ones digit in the bottom number, and this number is the ones digit in the top number. Are either of these numbers divisible by 2? This one is. Therefore, this number right here is divisible by 2, and this one is not. If we tried dividing this by 2, we could make it work, but it wouldn't be divisible by 2 to the point that we get a whole number, that we get a zero remainder in the end. We'd have to have some sort of either remainder or a decimal answer to it. Let's keep this going until we get to that point. Here we go. Notice we have nothing else to bring down, and we're left with a remainder of 1. So we could either say that the answer is 3,372 remainder 1, or we can add a decimal point, drop a 0, and then call it 0.5. It does not divide evenly by the number 2, does it? Now, if we tried it with this number, we would get an even number answer. So that's the divisibility rule for the number 2. So here's another number, 672518. Is that number divisible by 2? Well, you should be saying yes. Why? The ones digit, 8, is divisible by 2, therefore the entire number would be divisible by 2. How about the divisibility rule for 3? It says, if the sum of the digits is divisible by 3, then the number is divisible by 3. Let's take a look at an easy one. Here's a number, 63, and somebody says to you, hey, is 63 divisible by 3? Well, the way you figure it out is by taking the digits and adding them up. And then you ask yourself, is that number divisible by 3? It is. Therefore, 63 is divisible by 3. We'd say, yes, it's divisible by 3. How about a bigger number like 67152? 67,152. Is that number divisible by 3? Well, let's take all of the digits and add them up, because that's the rule on this. 13, 14, 19, 21. These numbers add up to 21. We then ask ourselves, is 21 divisible by 3? The answer is yes. Therefore, this number is divisible by 3. Let's prove it, just for the fun of it. Twice, twice again, 3 times, 8 times, and finally 4 times. 67,152 divided by 3 divides evenly into 22,384. Well, let's try the next rule, which is the divisibility rule for 5s. That's an easy one. If a number ends in 0 or 5, then it is divisible by 5. So here's a number, 7,460. Is that number divisible by 5? The answer is yes. How do I know that? It ends in a 0. If it ends in 0 or 5, it's divisible by 5. What about this number, 12,461? Is that divisible by 5? The answer is no. It doesn't end in a 0 or a 5. How about the next rule, the rule of 6s? A number is divisible by 6 if we know that the number is divisible by both 2 and 3. If it's divisible by both 2 and 3. Okay, so let's try a number. Let's write 146,712. Actually, that's a little difficult. Let's try something a little easier first. Let's go with the number 72. Let's start by checking to see, is that number divisible by 2? The divisibility rule for 2 says if it ends in a number that's divisible by 2, then it is divisible by 2. So yes to the concept of it divisible by 2. Is the number divisible by 3? Well, the rule for divisibility of 3 says add up the digits. I get 9. Is 9 divisible by 3? Yes. Since both the divisibility rule for 2 and 3 says yes, then that tells me that it's also divisible by 6. And I actually know that because, as you know, 72 divided by 6 is an exact number of 12. Okay, let's try this harder one. Is it, first of all, divisible by 2? And the answer is yes, it is divisible by 2. How do I know it's divisible by 2? Because it ends in a number that's divisible by 2, right? Is it divisible by 3? I don't know. Let's add up all the digits. 5, 11, 18, 19, 20, 21. The digits add up to 21. Is 21 divisible by 3? Yes. Therefore, is this number divisible by 6? It is, because if it's divisible by both 2 and by 3, then it's also divisible by 6. Okay? How about the next rule? An easy one. Is a number divisible by 10? Well, here's a number, 7,420. The rule says a number is divisible by 10 if it ends in 0. Is that divisible by 10? Yeah, it ends in 0. Therefore, we say yes. Let's prove it. Let's prove it. 7,420 divided by 10. 10 goes into this 7 times. It goes into this 4 times. And it goes into this 2 times. Voila, it's divisible by 10. Okay. Look at example 2 on 149. It says a bride must choose whether to rent 5, 6, or 10 people per table, or seat 5, 6, or 10 people at a table for her reception. And if there's 192 guests and she wants all of the tables to be exactly full, which one should she choose? And then so you've got those choices there. They tried dividing by 5, and that didn't work out evenly. They tried dividing by 6. That did work out evenly. They tried dividing by 10. That did not work out evenly. So the best answer is that she should have tables of 6 people each. Let's try it, everyone. What if somebody is running for student council president in her high school, and she wants to give out campaign flyers with a pen to each student in the school? She can buy Vote for Sonia pens in packages of 5, 6, or 10. So she can buy packages of pen in groups of 5, groups of 6, or groups of 10. Now, her particular school happens to have 306 students in it. If she wants to buy just the right amount of pens, should she buy packages of 5, packages of 6, or packages of 10? Well, does 5 divide evenly into 306? Not according to the divisibility rules. This number does not end in 5 or 0. Does 6 divide evenly into 306? The answer is yes. How do I know that? Well, this number is divisible by 2 because it ends in 6, which is divisible by 2. And it is divisible by 3 because when you add up the digits, you get 9, and 9 is divisible by 3. And since it's divisible by 2 and by 3, it must be divisible by 6. How about, is it divisible by 10? No, because it doesn't end in a 0. Therefore, if she wants to buy just the right amount of pens, she probably should buy them in packages of 6. Okay. Now, why are we talking about these divisibility rules? Well, the divisibility rules can help us to think through when we're trying to find factors of certain numbers. Look at example 3 on the bottom of the page. Example 3 on the bottom of the page says, list all of the factors of 72, and they're using the divisibility rules to help them do that. I'm going to do the same thing, but let's do it with the number 85. Let's do it with the number 85. So I'm going to start with the divisibility rules. Is this number divisible by 2? No, it's not, because it ends in 5, and 5 is not divisible by 2. Is it divisible by 3? Well, 8 plus 5 is 13. 13 is not divisible by 3, so therefore this number is not divisible by 3. Is it divisible by 4? No. If it's divisible by 4, it wouldn't end in a 5. How about, is it divisible by 5? Yes, it is. How many times does 5 go into 85? I don't know, but let's work it out here. I get 17 times. So far I know that 1 and 85 are factors of 85, and I know that 5 and 17 are factors of 85. Let's keep going. Is this divisible by 6? Nope, because it wasn't divisible by 2 or by 3. Is it divisible by 7? I don't know. Let's work it out. We don't have a divisibility rule for 7. Nope, it's not going to be divisible by 7. How about divisible by 8? No, that's not going to work. 9? No, I'm thinking of my math facts. 9 doesn't divide evenly into 85. 10? No. 11? No. 12? I think we're done. These are all of the factors of 85 right there. Those are all the factors of 85. Now, sometimes it works out pretty easy for a number, but what if we're talking about a number like 64? Well, first of all, I know that 1 times 64, these are 2 factors of 64. We're trying to find all of the factors of 64. Does 2 divide evenly into 64? Yep, it does. And it's actually the number 32 when you do the division. I know it's divisible by 2 because the last number is divisible by 2. How about 3? Is it divisible by 3? No, it isn't. Because when I add up the digits, 6 plus 4, I get 10, and 10 is not divisible by 3. How about the number 4? Is it divisible by 4? And the answer to that is yes. 4 goes into 64 16 times if I do the division work. How about 5? No, it doesn't end in a 5 or a 0. How about 6? No. If it's divisible by 6, it has to be divisible by 2 and by 3. And this one's not divisible by 3. How about 7? No. I know my math facts for 7, and 7 times no number gets me to 64. How about 8? Yeah, 8 times 8 works. How about 9? 9 doesn't work. Does 10 work? How about 11? 12? I think I'm done. Those are all the factors of 64. Those are all the factors of 64. Top of page 150, they're talking about something called monomials. Something called monomials. What in the world is a monomial? It says up there, a number such as 80 or an expression such as 8 times x is called a monomial. A monomial is a number, a variable, or a product of numbers and or variables. So if you look at the yellow and green table, on the left side they show you examples of monomials. On the right-hand side they show you examples of situations that are not monomials. How are they different? Well, do you notice that on the left side, none of those monomials have addition or subtraction signs? And on the right side, all of them have addition or subtraction signs? That might be a hint, right? Monomials are not going to have addition, subtraction signs within them, so keep on the lookout for something like that. So if I write the following above on the board, 6 times x times t, do you think that's a monomial? It is. There's no adding sign, there's no subtracting sign. We could also write this as 6 times the quantity of t times x, right? And bring it all together. That multiplication sign can be written like this. This is a monomial. What if I wrote 6x minus t? Would that be a monomial? No, it would not. This is one, and this is not. This has all multiplication signs. This has a multiplication sign and a subtraction sign. Be careful. You're not going to be grabbing the ones that have plus or minus signs. Those are not going to be considered monomials. How about something like this? What if I wrote 10x times 4y? Do you think that's a monomial? The answer is yes. Why, Mr. Ponko? Well, do you see any addition or subtraction signs? I don't. Additionally, we could simplify this. We could combine the 10 and the 4 together and then bring the x and the y together. This, in a simplified form, is 40 times x times y. That's a monomial. Therefore, this is a monomial. But this is still not a monomial because it's got that addition or subtraction sign in it. Okay, you have your assignment, folks. Hopefully this helps you. Thank you.